Assalamu alaikum student. This is Jasia Meher, your O-level computer science instructor. Today I will discuss about example 6 from your book chapter 10 Boolean Logic. The question given here that a safety system uses 3 inputs to a logic circuit. An alarm X sounds if input A represents on and input B represents off, or if input B represents on and input C represents off. For this particular condition, your alarm system will gives you sound. So you have to produce logic circuit and a truth table to show the condition that caused the output X to be 1. There are 3 inputs A, B, C and output is X. X equals to 1 if the condition given in your question will true. So your first condition is, so you have to on equals to 1. If on equals to 1, then you can write A. If off equals to 0, then you can write as not A. So first condition is input A represents on and input B represents off. So as input A represents on, so you can write here A. For AND, you can write AND. Input B represents off, so you have to write not B. Second condition is input B represents on, so you have to write here B, and input C represents off. As it is off, so you have to write here not C. This is your two logic expression. So you have to join this two logic expression with the OR operator. For A, for this logic expression, you can write this as a Boolean expression. So for A, you write here dot, and for dot is a multiplication sign, so you have to write here dot. B bar for not B, so you can write here B bar. For OR operator, you have to write addition sign, and B and not C, so you have to write here B, and for and multiplication sign dot, and not C, you have to write here C bar. So this is your Boolean expression. Now you have to make truth table and logic circuit. This is your logic expression. So now you have to draw your logic circuit. So for first expression, your logic circuit here, A direct goes to the AND logic gate, and not B as it is not B, so B go through the invert and it represent not B and go through AND operator, and B directly goes to the AND logic gate. C go through the invert, then goes to the AND operator, AND logic gate. This is the final version of your logic circuit. So these two logic circuit will join with the OR gate. So this is the final version of your logic circuit. You can produce your truth table from logic expression. It's useful to produce your truth table from the logic expression. So this is our truth table and this is our logic expression. We have 3 input, so 2 to the power 3 equals to 8. We have 8 input combination here. We have two logic expression. There are two logic in intermediate values. There are two logic expression. So first logic expression is A and not B. So we have to select the A column and B column. Since this is not B, so we have to reverse or invert all the value of the B column. So we can write here B bar, and we have to invert all the value of the B column. So 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0. Though this is the AND operation, so we know that AND is multiplication between the two input bits. So we have to do multiplication. 0 into 1 equals to 0, 0 into 1 equals to 0, 0 into 0 equals to 0, 0 into 0 equals to 0. 1 into 1 equals to 1, 1 equals to 1 equals to 1, 1 into 0 equals to 0, 1 into 0 equals to 0. Then this is the second logic expression. So we have to select B column and C column for this. So though this since there are not C, so we have to convert or invert all the value of the C column. So we can write here as a C bar. So 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So this is the AND operation. So we have to do multiplication. 0 into 1, 0, 0 into 0, 0, 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, 0 into 0, 0, 1 into 1, 1, 1 into 0, 0. Finally, we have to do OR operation between the two expressions. We know that OR is the addition between the two input bits. So we have to add these intermediate values, this logic expression. So 0 plus 0 equals to 0, 0 plus 1, 0 plus 0 equals to 0, 0 plus 1 equals to 1, 0 plus 0 equals to 0, 1 plus 0 equals to 1, 1 plus 0 equals to 1, 0 plus 1 equals to 1, 0 plus 0 equals to 1. So this is our output. We see that there are 4 output where there are output is a 1. So for this particular condition, output will give you 1. So if any of this logic expression is 1, then your output will be 1, or your alarm will gives you sound. Next, we will discuss about example number 7. Our question is, a wind turbine has a safety system which uses 3 inputs to a logic circuit. A certain combination of conditions results in an output X from the logic circuit being equal to 1. When the value of X equals to 1, then the wind turbine is shut down. The following table shows which parameters are being monitored and from the 3 inputs to the logic circuit. This is our table. This is very important. So you have to understand this table. There are 3 parameters we see here. Turbine speed S, bearing temperature T, wind velocity W. So This is our input. So each input has two values, 0 or 1. Here 0 turbine speed is less than or equals to 1000, then it is 0. If turbine speed is greater than 1000, then binary value is 1. Temperature, bearing temperature is less than or equal to 80 degrees centigrade, then the input value is 0. If bearing temperature is greater than 80 degrees centigrade, the input is 1. For wind velocity is less than or equals to 120, then your input is 0. Wind velocity is greater than 120, your input is 1. So your output X will give you 1 when the combinations of condition will occur. So any of the condition will true, then your wind turbine will shut down, and X equals to 1, and your wind turbine will be shut down. So you have to design the logic circuit and complete the truth table to produce a value of X equals to 1 when either of the three conditions above occur. So this is your condition. This is your condition. If any of the condition will occur, there are three conditions given in your question. So if any of the condition will occur, then X equals to your output will be 1 and wind turbine will be shut down. So when your input is 0, so you can write it as a not S. And when your input is 1 for turbine speed, you can write it as a S. If bearing temperature is 0, then you can write it not T. If your input is 1, then you can write it as a T. If wind velocity, your input is 0, then you can write it as a not W. And for one input, your wind velocity, you can write it as a W. So here your condition, you can write it as a this logic expression. So here says that the turbine speed is less than or equal to 1000. So you can write it this condition. So you can write it as a not S. And here is a and. So you can write it and T. For T, here says bearing temperature is greater than 80 degrees centigrade. Greater than 80 degrees centigrade, it is 1. So you can write it as a T. Second second condition is turbine speed is greater than 1000. Greater than 1000, so you can write it S. And wind velocity is greater than 120. Greater than 120, so you can write it as a W. And third condition is bearing temperature is less than or equal to 80 degree. Less than or equal to 80, so you can write it, it's 1, its input represents 1, so you can write it as a not T. And for and, you can write it as a and operator. And here wind velocity is greater than 120, so you can write it as though it is 1, so you have to write it here W. You have to join these three logic expression with the OR gate. So any of the condition may occur true, then your output will be 1. Here first logic expression is 1, so your output is 1. Here your second expression is 1, then your output will be 1. Here third expression is true, so your whole output will be 1. This is your logic expression. So you have to draw your logic circuit from this expression. So for first logic expression, here not S and T. So S is going through the invert and it becomes S bar and going to the AND gate, and T is directly go to the AND logic gate. And second logic expression, S and W directly goes to the AND logic gate. And third logic expression not T and W, wind velocity. T is going through the invert to the AND logic gate, and wind velocity W is directly go to the AND logic gate. So this is our final logic circuit. So first we have to join first two logic expression with the OR gate. Then the result of the first two expression will join to the third logic expression with the OR gate. So first we have to join this logic expression. Then the result of this logic expression will join to this third number logic expression with the OR gate. So this is our final output. So now we have to produce our logic truth table. So there are three input S, T, W. As we have three input, so we have 8 input combination. This is our intermediate values, not S and T. We can write it here, S and W, not T and W. So first, from the first logic expression we see here not S and T. So not S, since it is not operation, so we have to invert or reverse all the value of the S column. So 0 becomes 1, 0 becomes 1, 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, 1 becomes 0, 1 becomes 0. So we can write this column as a S bar. Now not S and T, we have to select S and T column, S bar and T column. So not S and T. We know that AND is the multiplication between the two operators, two input bits. So we have to do multiplication. 1 into 0 becomes 0, 1 into 0 becomes 0, 1 into 1 becomes 1, 1 into 1 becomes 1, 0 into 0 becomes 0, 0 into 0 becomes 0, 0 into 1 becomes 0, 0 into 1 becomes 0. Our next expression is S and W. So we have to do multiplication between S and W. So 0 into 0 becomes 0, 0 into 1 becomes 0, 0 into 0 becomes 0, 0 into 1 becomes 0, 1 into 0 becomes 0, 1 into 1 becomes 1, 1 into 0 becomes 0, 1 into 1 becomes 1. Our third expression is not T and W. So we have to select T column and W column. Since there is a not T, so we have to invert or reverse all the value of the T column, and we can write it here T bar. So 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0, 0 becomes 1, 0 becomes 1, 1 becomes 0, 1 becomes 0. So as this is the AND operation, so we have to do multiplication. So 1 into 0 becomes 0, 1 into 1 becomes 1, 0 into 0 becomes 0, 0 into 1 becomes 0, 1 into 0 becomes 0, 1 into 1 becomes 1, 0 into 0 becomes 0, 0 into 1 becomes 0. So this is the first logic expression, second logic expression, and third logic expression. Now we have to do OR operation or addition between the first and two expression. So we have to select first column and second column, and we have to do addition or operation between these two expression. So 0 plus 0 becomes 0, 0 plus We know that OR is a addition between the two input bits, so we have to do add operation. 0 plus 0 becomes 0, 0 plus 0 becomes 0, 1 plus 0 becomes 1, 1 plus 0 becomes 1, 0 plus 0 becomes 0, 0 plus 1 becomes 1, 0 plus 0 becomes 0, 0 plus 1 becomes 1. Now we have to join this expression, these results of these two expression with this third number expression. So 0 we can name it as it is a 4 number column. So 0 plus 0, we have to select 3 or 4 column. 0, and we have to join this with OR sign as it is the addition, so we have to do addition. 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, 1 plus 1, 1, 0 plus 0, 0, 0 plus 1, 1. This is our final output. We see here for the given for the particular condition where the output is 1 and output is 1 and the logic expression where the logic expression where our input is 1, then our output will be 1 and our wind turbine will be shut down. That's all for today. Allah Hafiz.